It's absolutely unsound. It's going to detonate. No, giving me won't be an astonishing opportunity to go for that. The thing is, it very well may be tomorrow, it very well may be during this transmission. What's more, it would gleam like a resulting sun over the James Webb Telescope. As of late, it has recognized an astonishing 250% expansion in the splendor of dreadful Crawley-Jew, the red star found at the shoulder of the Orion constellation. This capricious behavior has touched off energy for a captivating feature. Some suggest the unforeseen expansion in splendor could show that Betelgeuse is planning to go supernova, yet the particular timing remains questionable. Specialists gauge it could happen before long. Join us as we investigate the depths of space and disentangle the secrets surrounding this heavenly Goliath. Bug juice can potentially reshape how we understand the universe. Regardless of its name not being well known, you've probably noticed its splendor. A dazzling rosy shine transmitting at the shoulder of Orion, a noticeable star group. Bug juice's size is faltering. Whenever set at the center of our planetary system, its outer surface would extend past Jupiter's orbit. This beast star, easily visible, continues to charm us. Unlike most stars, insect juice varies in splendor over time because of its vicinity to our system, known as a semi-regular variable star. Its splendor changes occasionally, indicating a potential catastrophic breakdown in a cosmic explosion. As of late, bug juice has become significantly more dazzling due to sensational changes in brightness. These changes include a significant flood on May 20, 2023, when researchers took note of a bewildering 142% increment in splendor, followed by a later update showing a 150% expansion. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse currently ranks as the 7th most brilliant star in the night sky, climbing 3 spots from its usual 10th spot. From the southern hemisphere, Scarab juice shines brightly in the evening sky, easily visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, underlines insect juice's significance. It offers a captivating opportunity to study the final stage of a massive star's life, providing critical insights into the behavior of red giants before they detonate as supernovae. When bug juice eventually detonates, it could become incredibly bright for about 7 days, possibly creating shadows at night. This prospect has both amateur stargazers and expert astronomers eagerly anticipating the event. Heidi Morris, a researcher at Los Alamos National Laboratory and president of the Padaro Space Scientists and Cosmology Club, highlights the enduring interest in Betelgeuse's brightness changes, a phenomenon long overlooked by other cultures. Currently, Betelgeuse's brightness cycle lasts about 130 days, much shorter than its usual 400-day cycle. These rapid changes offer astronomers a unique opportunity to study this celestial phenomenon in detail, uncovering more about the last stages of a star's life. The strange behavior of Betelgeuse began in 2019 when it violently ejected part of its outer atmosphere. These changes in brightness are exceptional for Betelgeuse, igniting speculation about whether it will soon explode into a supernova. According to a paper by Dupree and other researchers from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle, as its light and outward velocity behavior have changed. Despite its erratic behavior, Betelgeuse remains a massive red supergiant star going through the final stages of rapid evolution. As it drains its fuel, the core will eventually collapse under its immense mass, resulting in a colossal explosion that could potentially darken entire galaxies. The timing of this explosion remains uncertain, as explained by Dr. Doc, a professor of astronomy at the University of Portsmouth. Predicting astronomical explosion events is challenging due to the limited historical data and the complexity of stellar evolution. Insect juice is currently undergoing fusion processes, constantly evolving through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon at its core, a process that takes millions of years. Ultimately, it will progress to fuse heavier elements until it can no longer sustain fusion reactions, leading to gravitational collapse and possibly forming a black hole or neutron star. While some hypothesize about Scarab juice's looming explosion, Historical records show that it has been growing red over the past few years, suggesting that it may take considerable time before it goes supernova. NASA estimates that Betelgeuse isn't expected to explode for another 100,000 years, offering comfort that its blast is unlikely to happen within our lifetimes. Despite the uncertainties in Betelgeuse's behavior, its changes continue to captivate researchers and inspire advances in our understanding of stellar evolution. Dr. Sarah Webb reminds us to stay open to all possibilities, even as we acknowledge that the probability of seeing Betelgeuse's explosion in our lifetimes is slim. Tracking its changes may lead to further scientific breakthroughs, allowing us to keep hope alive for new discoveries in the universe, remembering that it is significant. Our observations of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old, meaning Betelgeuse may have already exploded and we wouldn't yet know it. While this possibility exists, it remains uncertain. History has shown that our assumptions in space science can be challenged. Before 1987, astronomers believed that only red supergiants could go supernova. However, in that year, a massive blue star in another galaxy detonated, shocking the scientific community. There is still much to learn, and surprises may lie ahead. Observing Betelgeuse and other massive stars allows us to expand our understanding of celestial phenomena. No matter the lack of a looming explosion, Betelgeuse's ongoing behavior remains captivating. Its changes, both dimming and brightening, reveal fascinating physics. The fact that stars evolve on human timescales is remarkable. While Betelgeuse is currently much brighter than expected due to its irregular multi-day cycle, there is hope it will eventually return to this cycle. However, later observations suggest that Betelgeuse may be in its final stages, changing around the end of its core carbon-burning cycle. This stage involves the transformation of carbon into heavier elements like oxygen and magnesium. If so, researchers expect a core collapse, leading to a supernova that could happen within a few years. Nevertheless, the exact stage of Betelgeuse's evolution remains challenging to determine, and uncertainties persist. The chance of witnessing Betelgeuse's explosion remains unclear, as the carbon-burning phase can last up to 1,000 years, and the study suggesting an impending impact has yet to be accepted for publication. Nonetheless, the potential for Betelgeuse to become a supernova is exciting. It would be a rare event, visible even during the day for several days when the explosion finally occurs. The early signs of the stellar explosion will be subtle but undeniable, with neutrinos sweeping across Earth as high-energy photons escape from the expanding cloud of cosmic debris. Betelgeuse will gradually grow brighter in the night sky, perhaps reaching peak brightness 10,000 to 100,000 times its normal brightness within weeks. This event will astonish anyone lucky enough to witness it, marking a crucial point in time in cosmic history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon, packed into a single point of light. Incredibly, this brightness would be visible during the daytime, creating dramatic shadows at night. Estimates suggest that scarab juice could become 15 to 100 times brighter than Venus, currently the second brightest object in the evening sky. The display of Betelgeuse's explosion would last for at least 100 days, captivating space enthusiasts and offering a unique opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova would pose no threat to humanity, as it is still far away. Telescopes and optical instruments would allow us to observe the event without harm. Nevertheless, such a spectacular event would not go unnoticed. Supernovae are often interpreted as ominous signs, and Betelgeuse's demise could provoke intriguing reactions. Overall, astronomers believe it could indeed reignite widespread interest in stargazing, awakening people to the wonders of the universe. Scarab juice does not appear to be the only red supergiant in our galaxy. Others, like Edi Carni, could explode before it does. In fact, our Milky Way should experience a supernova about once every 30 years, but we haven't seen one in the last 400 years. However, we've observed the remnants of past explosions, indicating that we're overdue for a significant celestial event. It's only a matter of time before the next star goes supernova and the universe takes notice. Betelgeuse's history is rich with notable events, including the dramatic dimming in the fall of 2019. This sudden drop in brightness baffled astronomers and sparked speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the cause of its dimming remained a mystery until further observations provided insights into the phenomenon. Skywatchers can easily spot scarab juice from their homes, making it an accessible astronomical object to engage with. If a supernova occurs, it would undoubtedly provide an incredible celestial display. As we continue to monitor bug juice, the star remains a focal point of interest for both professional astronomers and amateur skywatchers alike. The ongoing changes in its brightness offer fascinating opportunities to study the cycles occurring within a dying star. With advanced technology, researchers can now examine Betelgeuse's behavior with unprecedented precision. Instruments like the James Webb Space Telescope, alongside ground-based observatories, are uncovering more secrets about this celestial giant. The study of supernovae, like the one Betelgeuse may ultimately become, has far-reaching implications beyond understanding the final stages of a star's life. These explosions play a critical role in the formation of elements heavier than iron, which are essential for the creation of planets, life, and the very universe we live in. In many ways, the death of stars like Betelgeuse contributes to the building blocks of the universe, enabling new stars and planets to form from the remnants of their exploded cores. Should Betelgeuse go supernova during our lifetime, it would offer an exceptional and breathtaking opportunity to witness such an event up close. For those lucky enough to observe it, it would be a once-in-a-lifetime spectacle. The light from the explosion would temporarily surpass all other stars, becoming a prominent feature in our sky as space experts rush to capture the data. The event would fuel further advancements in space exploration, enabling more research into stellar evolution, cosmic explosions, and the mysteries of the universe. Regardless of when it occurs, Betelgeuse's potential explosion will be a critical event for astronomy, expanding our understanding of star death and the life cycles of massive stars. The spectacle may also inspire future generations of astronomers, sparking an interest in the universe and encouraging people to look up in awe at the vast cosmos. As researchers continue to observe Betelgeuse's behavior, the mysteries surrounding its life cycle and impending explosion continue to spark interest across the scientific community. One of the most captivating aspects of this star is its volatility. While many stars display regular patterns of brightness, insect juice is anything but typical. The changes in its light output are not merely due to its normal fluctuation, but also the violent activity occurring in its outer layers. These eruptions, which expel material from the star's surface, are a sign of its instability and add an additional layer of interest to its potential for becoming a supernova. Betelgeuse's unpredictable behavior has kept astronomers and sky enthusiasts on edge. As a red supergiant, Betelgeuse represents the final stages of stellar evolution for a massive star. The most intriguing aspect of its behavior is the regular variation in its brightness. Unlike stars that shine steadily, Betelgeuse's intensity fluctuates due to its instability. This behavior has long been noted by astronomers, but recent changes have sparked renewed interest. With each burst of brightness, scientists gain insight into how a massive star behaves as it nears the end of its life. The variability in Betelgeuse's luminosity is not solely due to the normal pulsations of a red giant, but also due to more significant shifts, including violent eruptions of material from its surface. These eruptions are important because they give clues about the internal processes occurring as the star consumes its remaining fuel. In these late stages, the core of the star contracts under immense pressure, and the outer layers are pushed outward, creating the giant oscillations in its light output. Interestingly, as Betelgeuse is located roughly 640 light-years away from Earth, the light we see today actually left the star centuries ago. This means that its current state could already be far different from what we perceive. The vast distance between us and Betelgeuse also means that studying it requires sophisticated telescopes that can gather fine details from faint light sources. Instruments such as the Hubble Space Telescope and the recently launched James Webb Space Telescope are pivotal in providing higher resolution images and more accurate data. If Betelgeuse were to explode into a supernova in our lifetime, it would not just be a spectacular sight. It would be an opportunity to study a cosmic phenomenon in great detail. Such an event would send shockwaves through the scientific community, potentially leading to breakthroughs in our understanding of the fundamental physics that govern star death and the creation of heavy elements. While no one can predict exactly when this explosion will occur, the mere possibility keeps astronomers vigilant and eager for the next new discovery.